All right, percents, decimals, fractions. All of them are different ways to show the same number, yet we get completely confused on it. So I always show all three at once, and the more that we work with all three together, the better we're going to be when we see them. So the first example that I have here, I've got 100 squares inside of this big square, and 50 of them are shaded. And we want to know what percentage of the shape is blue. Well, it seems pretty simple, but I'm going to take you through all three phases of it. There are 50 blue squares shaded out of 100. So that right there tells me that I have a fraction of 50 shaded pieces out of 100. And the nice part about this is I can say this number as 50 100ths. And 50 100ths is nice because I can put that right into my decimal number. See, our decimal number has tenths and hundredths as a part of it. And so if I'm going to write 50 100ths as a decimal, I have to have my number take up both the tenths and the hundredths place value. And the number that I end at, well, that's how we say it. So 50 hundredths is what I end up with. Well, couldn't I write this decimal 50 hundredths a different way? Well, sure I could. And I could write 50 100ths as a fraction a different way also. We can reduce 50 100ths down by dividing both 50 and 100 by 10. That's going to give me 5 tenths. If I say the fraction 5 tenths, that decimal number could be written as 0.5. And all we are filling in is the tenths place. So this is one that confuses students because when they see this value here of 0.5, they tend to think that the percent has to be 5%, and that's not the case. When we deal with percents, we have to have both the tenths and the hundredths place value in order to create a percent. A lot of teachers will say the rule is move the decimal point 2 place values to the right for a percent and move it 2 place values to the left to make a decimal. In this case, we just got to understand that we want to keep it the tenths place value and the hundredths place value filled. If we keep that rule, we're going to end up with 50%. Now, do we have a completely reduced fraction? No, we have 100, 50 over 100, and we have 5 over 10. But what would our fraction, if they gave it to us, really look like to start? Well, 5 tenths can be completely reduced down if we divide both by 5 to 1/2. So we got to watch out for that. That might be coming up in another example, where they may not give us 100 squares to start off or 10 total boxes to start off. So here's a second example where they didn't give us 10 boxes and they didn't give us 100 boxes. This one, they gave us a circle, and there's 5 total pieces in that circle, and 3 of them are shaded. So the fraction that I have that's shaded is 3 out of 5. Well, that doesn't tell me how to write this as a decimal. So I'm going to create an equivalent fraction, and I'm going to jump counter. I'm going to double my fraction here to see what I get. I'm going to get 6, and 5, if I double that, is 10. Well, now I can write that as a decimal. 6 tenths means I have a 6 in the tenths place value. Well, that's great. Another way that I could write it is I could also fill the hundredths place value with that 0, and that helps me create my percent. I need the tenths place value and the hundredths place value filled in order to create the correct percent. So I end up with 60%. So we could write 0.60 as our decimal, or as we had to start, we can write it as 6 tenths. All right, so what do we got to watch out for so far? We got to watch out for percents that end in 0, like 60%, because they could look like 0.6. And we don't want to think that that's a single-digit percent. The other thing that we do have to watch out for also is single-digit percents. We haven't seen one yet, but if we see something like 3%, it's actually going to be written as a decimal as 0.03. Remember, we need the tenths place value and the hundredths place value filled. All right. Here's one more that's interesting because it's not going to be able to easily be changed into a fraction that has 10 as a denominator or 100 as a denominator. We have 4 total sections in the box and 3 of them are shaded. And so I have the fraction 3/4. Now, when my students did this, they tried to problem solve and they created 30/40, and then they created the equivalent fraction of 60/80, and that didn't work. So what they ended up realizing is we had to go to a different strategy for 3/4. And what we decided was we needed to make 100 out of 4 numbers. That's what this means. What could be the 4 numbers that we could have that make up 100? Well, what we realized was if we took 25 and we put that together 4 times, that would make 100. Well, the equivalent to 3/4 is using 3 of those numbers, and when we add those up, we get 75. So instead of 100 out of 100, we only want 3 of the numbers out of the 4 that we decided to use. 25 plus 25 plus 25 gives us 75. And now we have ourselves a fraction that we can say with either a tenths place value or a hundredths place value. This is 75/100ths. So we write, filling in the tenths and hundredths place as 75/100ths. This is easily converted to a percent because we have the tenths and the hundredths place value filled. So 75/100ths is the same thing as 75%.